This time question is saying that how many grams, this time it is not asking about the molarity. Molarity is provided to you in the question, that is 0.5 molar. And solution volume is also provided to you, that is 400 ml. This time you have to calculate in the 0.5 molar solution of 400 ml of solution of NaOH with water is already present here. This time you have to calculate how many grams of solute are present in that particular in that particular solution of NaOH. So how to solve this? This time again you will need the molecular weight of the NaOH. So NaOH molecular weight you have to calculate. So I'm calculating the molecular weight of the not glucose. This is NaOH. Molecular weight of NaOH, that is 23. Sodium's molecular weight, that is 23 multiplied by 1, because only one molecule of sodium is present here, plus 16 is the molecular weight of oxygen. 16 multiplied by 1 plus 1 multiplied by 1 is the molecular weight of hydrogen. So 23 plus 16, 39 plus 1 is equals to 40. 40 is the molecular weight of NaOH, sodium hydroxide. Now you have to calculate the number of moles according to the formula of molarity. That number of moles is not asking in the question, but we know that formula, that number of moles equals to weight divided by molecular weight. Molecular weight we have completed, already calculated. So weight we have to calculate how much or how many grams of NaOH are present in the solution. This we have to calculate. It means we have to calculate W divided by 40. 40 is the molecular weight. So put this all in the formula. Molarity equals to number of moles divided by volume of solution. Molarity is provided to you 0.5. So in the place of molarity, you can put 0.5. Number of moles, you can put W by 40. W by 40, you can see here. Volume of solution 400 ml. Again, you have to convert it into liter. This would be 0.4 liter. So here you can see 0.4 liter. W divided by 40 divided by 0.4. This 40 would be come to this denominator and multiplied by this 0.4, which is equals to W divided by 16. And we know that molarity of solution is 0.5. So 0.5 is equals to now W, which we have to calculate, divided by 16. So W is equals to 0.5 multiplied by 16. So this would be 8 grams. 16 5 80. So because it's 0.5, so 8 grams. So 8 grams would be your answer. So how many grams of NaOH would be present in 400 ml of 0.5 molar solution? 8 gram of NaOH solute would be present there in the 400 ml of 0.5 molar solution. So you can calculate anything. Number of moles you can calculate. Now the weight of that particular solute you can calculate. You can calculate molarity. You can calculate the volume of solution as well. If molarity is provided to you, number of moles is provided to you. So based on that, if by other entities you know, so you can calculate any one of them. So this is another example of the molarity question. Now again a question, this time it is saying that how many grams of acetic acid present in 100 ml of 0.1 molar solution? What is acetic acid? Acetic acid is what? Vinegar. Vinegar you can find out at your home. It is acetic acid. Formula of that acetic acid is CH3COOH. So based on this formula CH3COOH, you can calculate the molecular weight of the acetic acid. So this is molecular weight of acetic acid. C, 2 carbons are present, and this particular CH3COOH. So 12 multiplied by 2 multiplied by how many hydrogens are present? 3 plus 1, 4 hydrogens are present. So 4 multiplied by 1 plus 2 oxygen are present. So 16 divided by 16 multiplied by 2. This is 12 multiplied by 2 plus 1 multiplied by 4 plus 16 multiplied by 2, which is equals to 60. So the number of moles here is equals to weight divided by the molecular weight. Molecular weight is 60 here, so W divided by 60, number of moles. Molarity is provided to you 0.1 molar, so 0.1 you can put in the place of molarity. In the case of number of moles, put W divided by 60 divided by 0.1. 0.1 is the volume of the solution, 100 ml. So you have to put it in the form of liters. So this would be 0.1 liter. So 0.1 liter and in here, so this would be 60 multiplied by 0.1, that is W divided by 6 only. Now put the value of molarity here, that is 0.1 is equal to W divided by 6. W would be 6 multiplied by 0.1. So the unit or the number of weight, weight of the acetic acid that is present in 100 ml of 0.1 molar solution, that is how much? That is 0.6 gram only. So another same type of question. The reason behind of doing the same type of question here, you should know the basic molecular weight calculation and basic formula of few substances which are very, very common, like acetic acid, glucose. So these would be beneficial to you while you are attending these type of questions. Another important concept apart from molarity and molality that you have to be very clear, that is the normality. Normality Normality is noted with the help of capital N. So normality capital N is equals to, now in the place of number of moles, here new term will come. That is the number of gram equivalent of the solute present in the water. What is gram equivalent? It is divided by, again that would be the same with molarity, that is volume of the solution. Now how to calculate number of gram equivalent? As in the name you can see, this is gram in per gram equivalent. It means weight in per gram equivalent. So this is weight divided by equivalent weight of that particular solute, which is present in the solution. Now what is equivalent weight? Equivalent weight is generally calculated with this formula. Equivalent weight is somewhat different from molecular weight. How it is different? The equivalent weight is generally calculated with the help of molecular weight. So how to calculate equivalent weight? That is molecular weight divided by the valency factor, or this valency factor is also known as Z factor. What is the valency factor? What is the Z factor? Suppose you are calculating this for a particular ion. Which ion? Let's see, hydrogen ion. So for the ions, this valency or Z factor is the ion present in that particular element. So here one positive ion is present. So the valency or Z factor would be 1. Another thing about the hydrogen is that if you put one electron, if you give one electron to this hydrogen, the valency or the number of electrons required to be stable, that would be satisfied with one electron. So here the Z factor, the valency factor for hydrogen will be 1. If you take any other element, for example, if I take chlorine, so chlorine also need one electron. Hydrogen will give one electron. Chlorine will take one electron. But with the help of one electron, this can satisfy its valency factor. So valency factor would be the number of ions maybe, or maybe the number of electrons required, or the element is ready to give to complete its valency. That would be valency of that particular element. I take calcium. So calcium valency factor would be 2, because calcium can give 2 electrons to satisfy its optical composition or its valency. So that is the valency factor. This can be different for different elements, it can be different for the different molecules or atoms or maybe compounds. So this is how you can calculate the valency factor. This is different from the molecular weight. For example, for hydrogen, chlorine, these are having one valency factor or Z factor. So there would be no change in the equivalent weight. Equivalent weight would be equal to molecular weight. But suppose if the valency factor, Z factor is different for any particular element, so the molecular weight would be different from this equivalent weight. So how you can calculate the normality? First, you have to calculate the equivalent weight. Equivalent weight will be molecular weight divided by the valency. The first work you need to do. Then the second thing you have to do is calculate the number of gram equivalent. Number of gram equivalent would be the weight you have of that particular solute divided by the equivalent weight you have calculated. Then put this value in the third formula, that is the normality. So how you can do that? That is just the number of gram equivalent you have calculated here divided by volume of solution. That's all you have to do. You will get the normality of any particular element. If you look at this particular formula, everything is same with the molarity, but only introduction of one thing here, that is the valency or Z factor. This is what differentiating this normality with the molarity. Remember that if I put the valency factor, Z factor value 1, this is equals to molecular weight, and then number of gram equivalent would be also same with the molecular weight. So in the place of number of gram equivalent, you can put molecular weight. So now that is the formula of molarity. But what if the valency of Z factor is different, not 1, it is 2 or it is 3, then the normality and molarity of that particular solution would be different. If that solution is suppose hydrochloric acid, then what? Then the valency factor here is 1. So molarity and normality both would be equal. But what if it is any other solution, like it is calcium sulfate, for example, CaSO4. Now the valency factor is 2 for the calcium. So now that particular calcium sulfate solution will have different normality and different molarity. So the only difference which is defining the normality and molarity difference, which is differentiating them, that is the Z factor or the valency factor. So you can say that the molarity and normality relation is like this. How you can calculate it? Normality? Normality is equals to the molarity multiplied by Z or valency factor of that particular solute. So now you can calculate, you can convert the normality to molarity, you can convert molarity to normality with this particular formula. This is shortcut you can suppose in the question normality is provided, you can calculate the molarity. If you can molarity is provided, you can calculate the normality. Although you should know the value of valency factor, Z factor. That's all as required. You can see that the valency of Z factor is divided here in the normality, right? And then it is reducing the normality value here. You can say a number of gram equivalent we have calculated. Once you multiply it with the molarity, both will be equal. Molarity is a little bit less as compared to normality here in this scenario. So this is how you can calculate normality, molarity, and this is how you can convert normality to molarity, molarity to normality. So remember these formula that would be enough to calculate normality, molarity, or conversion of these to each other. Now let's see some questions of the normality as well. Then things would be more. Question is saying that calculate the number of milliequivalent of H2SO4 in 10 ml of 0.5 normal solution. Now here you can see this is H2SO4, sulfuric acid. So we know that normality equals to number of gram equivalent divided by volume of solution. Volume of solution which is provided here is the 10 ml. I can write down this is 0.01 liter because we have to put the value in liter. So the gram equivalent divided by 0.01. Now here is you can see this is just asking the milli equivalent. So do not put the gram equivalent formula here because we need the gram equivalent on. Once we got the gram equivalent, we will convert it into milli equivalent. There is no need of putting the formula of gram equivalent. Number of gram equivalent here would be 0.01 multiplied by normality of the solution. 0.01 will go to this side. Normality of the solution is provided to you, that is 0.5. So 0.5 normal multiplied by 0.01, that is equals to 0.005. 0.005 would be equals to 5 milli equivalent. So basically, we have multiplied 1000 here to convert it into milli form. So to convert it into milli form, just multiply 1000, we will get the milli equivalent because in milli there are 1000, but 1000 amount. That is how you can convert milli form. Milli is 10 to the power 3. So this is very basic question from the normality. Now another concept that we have to cover here in this particular chapter, that is the ppm, parts per million, and then how you can convert this ppm to percentage or maybe any other unit. So in the name itself, you can see what is ppm. ppm is nothing but its parts per million. So how many parts you are having in 1 million amount, that would be your ppm. Suppose you have 1 million sand particles, sand, and in this sand you don't have water. Suppose you mix sugar with it. And the number of the particles of sugar you have is suppose 100 sugar particles. Sugar cubes maybe or sugar particles maybe you have mixed them. Now, what you will say, this mixture is what? This mixture is mixture of sugar and sand, which is how much? It is 100 ppm. 100 ppm parts per million of sugar is present in this particular mixture of sand and cube. So the same we can calculate it for any other solution as well. So ppm is basically 1 divided by 10 lakhs. Million is what? Million is equals to 10 lakh. We have in India like thousand, 10,000, then lakhs, 10 lakhs, that kind of system. But in the European countries or in the Western world, we have the thousand, 10,000, then million. Million is 10 lakhs. After million, we have billion. So that's how you have. You can split it by the power aspect. 10 to the power 6 is million. Let's suppose billion. Billion would be 10 to the power 900 crores. So that is how you can calculate the ppm. Similarly, in the percent is what? Percent. Cent means 100. So how many per you have in 100 or in cent? So that is 1 divided by 100, that is percent. In ppm, how many parts you have in per million? That is 1 divided by 10 lakhs. How to convert these into each other? ppm to percentage, percentage to ppm. So you can see that, you can remember this as well if you have any kind of confusion in converting them. So that is 1% is equals to 10,000 ppm. So suppose I have 1% solution of sulfuric acid in 1 liter of water. So that is equals to 10,000 ppm. So just basic formula you can remember, or you can also remember that if I have 1 ppm solution of H2SO4, so that is 1 divided by 10,000% or 0.0001% of the solution. If you ask to me how I convert the ppm to percentage or percentage to ppm, always remember that the ppm is in per million, percent is in per 100. So always the percent value would be higher as compared to ppm. For ppm value would be higher here. Percentage you can see I am having only one here. This one is equals to 10,000 ppm. So ppm is a smaller unit. So generally we have a smaller unit in large unit. It is obvious. So that's why we are giving 10,000 ppm here. It is equals to only 1%. So you can remember this like which is bigger and which is smaller. Suppose you are converting percentage to ppm. So percentage to ppm, you will always having suppose x number of percentage. You are converting into y ppm. So this y ppm value would be always larger as compared to this x. Suppose x is 100. So this would be 10, 0, 0, 0, and another 0, 0. It means what is the basic funda here? Basic funda is that the percentage number would be always smaller than the ppm value. So by that way, you can also convert the ppm to percentage. If you are converting ppm to percentage, so the number will get smaller. If you are converting percentage to ppm, the number will go larger. And the difference in between these are 10 to the power 4. The difference in between them is how much? How much? That is 10 to the power 4 or 10,000. So suppose you are converting percentage to ppm, so it means the number will go larger. So multiply 10 to the power 4. If you are converting opposite, then number will get smaller, ppm to percentage. Then divide it by the 10 to the power 4. That's all you have to do. Otherwise, if it is looking difficult to you, just go with this particular formula. 1% is equals to 10,000 ppm. So 100% is equals to, according to that, divide or multiply if it is convenient. Otherwise, the concept I have provided that can also be used. This is the concept of ppm and percentage. Now, parts per million. How you can calculate parts per million of any particular solution? So for that, already we have this formula. 1 ppm, generally in 1 ppm solution. Suppose you want to create 1 ppm solution of any solution. So what you have to do? Just take 1 milligram substance of that particular solute and dissolve it in the 1 liter of the water or solution. So the amount you will get that would be equals to always 1 ppm. So this is the basic calculation of fund of creating ppm solution. Suppose your instructor tell you that create 100 ppm solution. Suppose he is saying that suppose your instruction is saying that create 100 ppm of any solution. Suppose sugar. What you will do? You will take 100 milligram of sugar and you will take 1 liter of solution, water. Now the solution you will create that would be 100 ppm solution of sugar in water. This is the basic funda. I can again more clarify it or more get more convenience here. That is 1 milligram. In 1 milligram we have 1000 microgram. Microgram is more smaller. That is 1000. Another time added here to convert 1 gram to 1 microgram or equals to microgram, that would be 1000 microgram. Divided by 1 liter. In 1 liter we have 1000 ml, 10 to the power 3 ml. So now 10 to the power 3, 10 to the power 3 get cancelled, and it is now equals to 1 microgram divided by 1 ml. Suppose this time your instructor is saying that don't create 1 liter volume of solution. That is too much. What we will do of that? Only create 10 ml of solution that you are creating 100 ppm. So what you will do? In the 10 ml, you have to add 1 microgram of the substance. In 1 ml, you have to add only 1 microgram of the substance. So add 10 microgram of sugar. You will create 1 ppm solution. Suppose you want to create 100 ppm. So again multiplied with 100. So that would be 1000 microgram. Or you will say 1 milligram. So in the 10 ml of solution, if you add 1 milligram of the sugar, that would be close to 1 ppm of solution. Now suppose your instruction is saying that how much would be less in 1 percentage, or you are creating suppose percentage solution, 1% solution. In the 1% solution, again there is already provided equation, that is 10 gram of the solute in 1000 ml, that would be equals to 1% of the solution. Or I can convert it into milligram as well. So again multiplied with the 1000, because milli is equals to 1000. So 10 multiplied by 1000, that is 10,000 milligram divided by the 1 liter. So this would be equals to 1% of solution. So you can create now, I hope, ppm solution as well as percentage solution equally. If you know this particular formula, you can create any amount of ppm solution, parts per million solution, and any amount of percent solution with this particular formula. Remember always, this is very important, 1 microgram in 1 ml. You can accordingly convert as well. 1 milligram in 1 liter, you can also remember. These two are important. If you are creating 1% solution, that is 10 gram in 1000 ml. Because how it is calculated? Simply calculate 10% of 1000. So that would be 1000 multiplied by 10 divided by 100. Cancel. You can see that is equals to 100%. In percent means in per 100. You can see that in per 100, how much you have to calculate? You have to add 10 gram only. You will create 1% of the solution. So that is how it is calculated. Similarly, this one is calculated. Now, how to convert ppm to ppb and vice versa? So again, use the same concept, the larger unit or a smaller unit. So the ppb would be larger value here. Suppose ppm is x and ppb is y. So this y value would be always larger, because in 1 billion you will have more particles. In 1 million you will have less particles. And 1 ppb, we know that billion is 10 to the power 9. So 1 divided by 10 to the power 9 is your ppb. So there is a difference of how much? Difference of 10 to the power 3. Because in parts per million, we have 10 to the power 6. In parts per billion, we have 10 to the power 9. The difference between 10 to the power 6 and 10 to the power 9 is difference of 1000 particles. Difference of 10 to the power, difference of 10 to the power 3 particles. So suppose you have X amount of ppm, you have to convert that unit into ppb. So multiply 10 to the power 3, because this is a smaller unit. So more numbers would be required. And if you are converting vice versa, ppb to ppm, so now the unit is larger here. So the amount of this particular X or Y, whatever you are having, that would be going to reduce. So divide it by the 10. So same thing. Used here 1 ppb equals to 1 divided by 1000 ppm, or 1 ppm is equals to 1000 multiplied by 1 ppb. That's how you can convert ppm to ppb to ppm. So this is another very basic concept of the environmental chemistry.